Welcome everyone. Today we're diving deep into the world of computers to explore their different classifications. What is a supercomputer? A supercomputer is the very fastest, powerful, and expensive type of computer for processing data. Supercomputer size and storage capacity are also huge, can occupy huge premises, designed to process vast amounts of data in a short time with high productivity. These are specially made to perform multi-specific tasks. Therefore, many CPUs work in parallel order on these supercomputers. This function of a supercomputer is called multiprocessing or parallel processing. Each part of a supercomputer is responsible for its own specific task, such as structuring and solving the most complex problems requiring an incredible amount of calculations. We can use supercomputers in research and study of energy, nuclear weapons, designing the aircraft, airplanes, and flight simulators. Another usage of supercomputers are for climate research and weather forecasting and predictions of natural disasters. Spaceships and satellite launching used in scientific research laboratories, and lastly used in chemical and biological research and for highly calculations complex tasks. Let's take a look at this video about the IBM Roadrunner.
Did you know the most expensive computer ever built cost $133 million? Meet IBM Roadrunner. In 2008, IBM unveiled Roadrunner, a supercomputer designed for the US Department of Energy. Roadrunner was the first computer to break the petaflop barrier, capable of performing over 1 quadrillion calculations per second. This unprecedented speed was achieved by combining traditional processors with specialized accelerators. IBM Roadrunner's $133 million price tag reflected its cutting-edge technology and groundbreaking performance. It was used for complex simulations and research, including nuclear weapons testing and climate modeling. Stay tuned to learn more about how IBM Roadrunner pushed the boundaries of computing power and its lasting impact on technology.
And that is the best example of a supercomputer.
Computers and the basis of hardware design and data handling. Number 1. Analog computer. An analog computer performs tasks using continuous data, the physical amount that changes continuously. Analog computers are used primarily to measure physical units like the voltage, pressure, electric current, temperature, and convert them into digits. It is also used to measure and perform arithmetic calculations of numbers, the length of an object, or the amount of voltage that passes through a point in an electrical circuit. Analog computers obtain all their data from some measurement way. Analog computers are mainly used in the fields of science and engineering. Analog computers are slow and equipped to measure things rather than countable or check. Analog computers work by using continuous data, such as temperature or voltage, to perform tasks. They primarily measure physical units like voltage, pressure, electric current, and temperature, converting these measurements into digits. These computers are commonly used in science and engineering for tasks involving measurements and arithmetic calculations, such as determining the length of an object or the voltage in an electric circuit. So this picture shows the analog computer. So the example of analog computer is installed on a computer pump, measures the amount of petrol coming out of the pump and appears in liters, and calculate its value. These quantities vary continuously while measuring the amount, such as the temperature of a human body changes consistently. So let's proceed to number 2. This is digital computer. As its name suggests, a digital computer represents the digital computer's letters, numerical values, or any other special symbols. This computer is the computer that calculates the number for processing the data. They run on electronic signs and the binary numeral method. Binary system 0 or 1 is used for calculation. Their speed is fast. It can perform arithmetic operations such as addition, occurrence, subtractions, multiplications, or division, and all types of logical, like mathematical operations. Today, the most of computers available in the market are digital computers. The desktop or laptop at our home is one of the common and best example of a digital computer. So this is the example of digital computer. So the other examples of digital computers are the personal desktop computers, calculators, laptops, smartphones, and tablets, and also digital watch, accounting machines, workstation, digital clock, and etc. So those are the examples of digital computers.
Mini computer. What is mini computer? Mini computer is a digital and multi-user computer system with the connection of more than one CPU. Thus many people can work on this computer simultaneously instead of a single person. Also, it can process with other accessories like a printer, plotter, etc. Mini computers are the medium types of computers that have more functionality power and are expensive than microcomputers. On the other hand, the size, storage, and speed of mini computers are large but less than the mainframe and supercomputers. The uses of mini computers. The mini computers are used as a real-time application in the industries, bookings, and research centers. Banks also use mini computers for preparing payroll for employees' salaries, records, tracking of financial accounts, and etc., as well as in the field of higher education and engineering. Example of mini computers: PDP-11 and IBM E1000 series.
Mainframe. A mainframe is a large, powerful computer used by big organizations for critical tasks like bulk data processing and handling millions of transactions. Securely and reliably, it supports thousands of users at once. Common uses: banks, finance, ATM, online banking, credit cards. Government: census, taxes, social services. Airlines: flight reservations. Corporations: payroll, supply chain, ARP. For example, when you withdraw money from an ATM, a mainframe computer in the bank's data center processes and verifies the transaction almost instantly. Mainframes keep our modern world running smoothly. And that's all. Thank you.
Digital computer. A digital computer is a type of a computer that processes information using binary digits 0 and 1. It works with a discrete value instead of continuous signals like an analog computer. Key features of a digital computer. Uses binary system is for data and instruction or performs tasks such as calculation, data storage, and logical operations. Very accurate and fast compared to analog computers. Examples: laptops, desktops, smartphones, and tablet.
Hybrid computer. A hybrid computer merges analog and digital properties into one complex system, operating under a unified control to harness the strength of both computing types. Second, designed to deliver features and functions found in both analog and digital computers, providing versatile computing capabilities. Hybrid computers perform complex calculations extremely fast, excelling at solving complicated equations rapidly and efficiently. Despite their advanced capabilities and speed, hybrid computers tend to be costly and are specially made to handle highly complex problems efficiently. Key features and advantages of hybrid computers. Hybrid computers combine the strength of both analog and digital components to handle a wider range of tasks efficiently. They excel at rapid calculations, making them ideal for tasks that require high-speed mathematical processing. The control system smoothly coordinates analog and digital functions, ensuring efficient and synchronized performance. Hybrid computers tackle challenging problems that neither an analog or digital computer can efficiently solve individually. The advanced integration and technology that make hybrid computers costly investment compared to simpler systems. Ideal for specialized field, they deliver results quickly under rigorous conditions. What are the applications of hybrid computers? First, essential for solving complex equations in industries, research center, and manufacturing firms. Delivers detailed and useful results across multiple fields requiring precision. And critical roles in science and defense, used in scientific calculation, national defense, and radar system for vital operations. Auto gasoline pump measures petrol quantity and calculate costs simultaneously, showing hybrid capabilities. Combined measurement and computation. Application reflects the hybrid computer's ability to integrate data collection with processing. Technical insights on hybrid computers. Use of analog components. Analog parts enable fast real-time processing of continuous data signal. Use of digital components. Digital parts handle complex data manipulation and discrete computations. Next, integration of analog and digital. Combines continuous and discrete data processing for solving complex equations. And supports high speed, precision, and reliability. Designed for applications demanding rapid and accurate computation. Limited widespread use. High cost and complexity restrict usage to specialized fields. Bridging analog and digital technologies. Hybrid computers connect the gap between analog and digital computation methods. And that's all about hybrid computers.